Welcome to the National Energy Technology Laboratory. I'm Brian Anderson, Director of NETL. Our lab is at the forefront of creating technological solutions to America's energy challenges. For generations, our nation's domestic fossil energy resources, coal, oil, and natural gas, have underpinned our prosperity. NETL has long played a key role in that prosperity by delivering innovations to ensure those resources are used efficiently and with responsible stewardship of the environment, protecting our air and water resources. NETL is one lab with capabilities at 3 physical locations: Albany, Oregon, Morgantown, West Virginia, and Pittsburgh, Pennsylvania. Our work extends beyond these regions through robust partnerships with academia, industry, nonprofits, non-governmental agencies, and other public sector organizations across the nation. As the only DOE national laboratory that is both government-owned and operated, NETL is uniquely suited to accelerate the development of technology solutions through strategic partnerships. NETL is also the only national lab dedicated to fossil energy research and development, which makes our team a sought-after national and international resource. Our lab is a hidden gem that is having a global impact, and the results of our research have touched the lives of millions of individual Americans as they go about their daily lives. From pioneering the technologies that enabled the shale gas revolution, to spearheading carbon capture and storage innovations and developing materials for next-generation energy systems, our forward-looking research continues to position NETL as the nation's renowned fossil energy science and engineering resource.
Welcome to NETL. I'm Sean Plazinski, Deputy Director and Chief Operating Officer. NETL's Laboratory Operations Center manages a comprehensive, fully integrated suite of laboratory support services consistent with the NETL mission. Specifically, the laboratory operations responsibilities span facility operations, information technology, environmental safety and health, security and counterintelligence, records management, and human resources. The laboratory operations day-to-day support performed by the site operations support contractor include R&D support services, which includes the technicians and operators necessary to operate the R&D equipment in our laboratories, and provides safety and engineering support for laboratory safety reviews and design of laboratory equipment. It includes R&D equipment and materials, which includes the purchase and receipt for the research areas. Engineering and facility support services, which includes the general engineering labor and materials necessary to complete the engineering, design, drafting, and drawing for various areas such as civil, mechanical, electrical, plumbing, utility locating, and construction inspection services. The facility support includes maintaining the sites, motor pool and shuttle services, warehouse and property management, janitorial and grounds maintenance for the Pittsburgh site. Environmental safety and health support services includes activities like air, water, and waste control, environmental data analysis, inspection support, occupational health, which includes access to nurses and physicians, just to name a few of the services they provide. Safety program that includes reviews of operations, inspections and analysis, emergency notifications, fire and life safety protection, accident and incident identification. Risk management and response program includes supporting the emergency management program through drills, training, and reporting. For example, the industrial hygiene program includes exposure and workplace monitoring, ventilation program, radiation monitoring, and these are just to name a few. And the environmental remediation and disposal services include some site monitoring in Wyoming, reporting and compliance with regulatory requirements, identification, characterization, and classification of regulated waste items, and processing items for chemical storage and waste disposal. The NETL complex includes multiple sites operating as a one lab system. The lab's 3 R&D campuses are located in Morgantown, West Virginia, Pittsburgh, Pennsylvania, and Albany, Oregon. Let's take a closer look at our 3 research campuses.
NETL's Morgantown site was founded after World War II sparked national interest in synthetic fuels production and expanded federal support for research and development on fossil fuels. The Appalachian Experiment Station, as it was then known, was tasked with finding quicker, cheaper ways of gasifying coal to produce synthesis gas. Today, the Morgantown site plays a pivotal role in advancing innovative energy science and engineering with a focus on design and fabrication technologies, including unique specialty work. The site encompasses 48 buildings spanning 455,724 square feet, spread across nearly 140 acres. About 40 acres are occupied by site facilities that house 612 employees, including 226 federal and 386 contract workers. The remaining 100 acres is covered with scenic woods that offer privacy and security. The replacement value of the Morgantown site facilities is nearly $247 million, with the newest addition, the B39 Technology Support Facility, built in 2008. The building is LEED certified, with a gold rating for the energy conservation incorporated into its design, which includes sustainable building practices and materials, a green roof, and judicious use of natural light and lighting controls for energy efficiency. Let's take a look at some of our premier research labs in Morgantown. B14, the newly created Reaction Analysis and Chemical Transformation Facility, or REACT for short, supports NETL's energy conversion engineering efforts to increase power cycle efficiency and enable more power generation for less fuel and fewer emissions. The REACT facility features 8 unique reactor systems, including a mix of high-temperature, pressure-fixed, and fluidized reactors, as well as advanced microwave and plasma-energized systems. The facility is fuel-flexible, enabling the study of a variety of feedstocks and designed for fully automated 24/7 operations. B4. This building houses 3 unique laboratories. The Hybrid Power Systems Performance Lab is the only hardware-based cyber-physical simulation of an advanced hybrid power system anywhere in the world. This one-of-a-kind facility is being used to develop control strategies and explore operating flexibilities for the reliable coupling of fuel cell and gas turbine technologies. The Chemical Looping Reactor Facility is a pilot-scale reactor facility that aims to advance transformational chemical looping combustion technology. The solid oxide fuel cell manufacturing and test labs are equipped to test solid oxide fuel cells and component materials at temperatures up to 1,000 degrees Celsius under various gas atmospheres and operational conditions. B6, the high-pressure gas turbine combustion facility, offers the test capabilities necessary to evaluate new combustion concepts for high-pressure, high-temperature hydrogen and natural gas turbines. To model and study fluid flow and combustion variability, researchers use computational fluid dynamics and the Dynamic Gas Turbine Combustion Test Rig to gain insights into complex combustion processes. The Simulation Validation, or SimVal unit, is a unique optical combustor for analyzing high-pressure combustion and validating computational fluid dynamics models. B17, the Geological Sciences Lab, houses NETL's computer-aided tomography, or CT, equipment, which is used to obtain data of flow dynamics and internal structures of geologic media. The lab's 3 CT scanners, medical, industrial, and micro, enable researchers to examine different phenomena from dynamic fluid floods within rocks at in situ conditions to the isolation complex of pore structures and material features. Research in this facility is focused on examining the fundamental physical phenomena that control flow in the subsurface, including geologic carbon storage, gas and oil production, wellbore integrity, and flow through fractured rock. B25. This building also serves multiple purposes, housing several critical laboratories. The Multiphase Flow Analysis Laboratory provides tools for fundamental tests on particles and flowing particle systems to support multiphase model development and validation. The lab has capabilities to perform detailed characterization of particles for a broad range of fluidization and particle flow systems. These capabilities provide fundamental information for accurate computational modeling, as well as high-quality data for validation of model predictions. The Laser Laboratory is used to develop and demonstrate laser-based sensor technologies that allow for monitoring under extreme conditions, such as high temperature and pressure, for incorporation with advanced next-generation control systems. Joule is among the world's fastest, largest, and most energy-efficient high-performance computers. The system underwent a $16.5 million investment that increased its computational power by 8 times, ranking it 23rd in the United States and 52nd in the world. Joule 2.0 is housed in an energy-efficient modular data center. Similar to a large air handling unit, the facility circulates ambient air, moved by 48 variable-speed fans, augmented with evaporative media to cool the supercomputer using just 2 to 5% of the power consumed. In addition to offices and laboratories, the NETL Morgantown site features a large machine shop with both traditional and state-of-the-art computerized numerical control machining capabilities, a children's daycare facility that has geothermal heating and cooling, as well as solar power and lighting features, a fitness center, an occupational health unit, an independently operated cafeteria, and a 349-space parking garage. Morgantown also has several unique infrastructure capabilities, including a dedicated water treatment collection and processing facility for industrial waste, a 23 kilovolt to 4,160 volt electrical substation and underground distribution network, a compressed gas system that provides 100 and 700 psi air, compressed nitrogen, compressed natural gas, and high-pressure hydrogen, an essential steam boiler and chiller that serves several facilities throughout the site. In support of the R&D program, a dedicated process cooling tower and associated underground distribution system provides process cooling water to buildings 4 and 6. A motor pool area is designed to maintain NETL's fleet of vehicles, which includes alternative fuel vehicles and shuttle vans used 4 days a week to facilitate travel between the Morgantown and Pittsburgh sites. Snow removal from roadways is included in site operations and features a dedicated bulk salt storage facility. NETL Morgantown also features a large warehouse and a dedicated hazardous waste handling facility where regulated materials are collected and prepared for disposal. Field communications capabilities at the facility are enhanced by a dedicated radio repeater system with dedicated channels for operations and other groups. NETL is an ISO 14001 and OSAS 18001 certified facility. Key aspects of the environmental support functions at the facility include dedicated groundwater monitoring wells, stormwater management and protection as well as associated sampling, and industrial wastewater system operation, which is permitted through publicly owned treatment works. The Morgantown facility does not currently require an air permit, but air emissions are inventoried to ensure ongoing compliance. NETL is an OSHA-regulated site, and safety oversight is provided by a mix of federal and contractor workers. Other significant support efforts managed by the Environmental Safety and Health Program include safety analysis and review systems, industrial hygiene, emergency response, and technical support of external remediation efforts that are federally managed from Morgantown. NETL's Pittsburgh site is located within Allegheny County, Pennsylvania, at the Brewston Research Center, approximately 13 miles south of Pittsburgh in South Park Township. NETL shares the Brewston Research Center with CDC NIOSH, the Center for Disease Control National Institution for Occupational Safety and Health. The U.S. Department of Labor's Mine Safety and Health Administration also occupies part of the CDC NIOSH grounds. NETL Pittsburgh is unique among NETL's research sites because it comprises 4 separate facility plateaus: administration, research laboratories, daycare facility, and a fitness center. Employees access various roads, including township, state, and railroad crossings, to travel between the various plateaus, in some cases passing through CDC NIOSH. The lab has an assets replacement value of $207 million. 547 employees work at NETL Pittsburgh, including 224 federal and 323 contractor staff. The site operations support contract supports NETL Pittsburgh's 30 buildings and 57 acres, including janitorial and ground services. The campus holds 431,000 square feet of building space, including a maintenance shop, a warehouse, a recycling facility, a children's daycare facility, and a fitness center. Pittsburgh also has several unique infrastructure capabilities, including a dedicated chemical handling facility where regulated materials are accumulated for disposal, a dedicated wastewater treatment collection and processing facility for industrial wastewater, a machine shop, a compressed air system that provides 100 psi air to laboratory buildings, a 100 psi nitrogen distribution system, including an 11,000-gallon liquid nitrogen storage tank with a liquid nitrogen Dewar filling station, an electrical substation, an occupational health unit, and an independently operated cafeteria, A motor pool area is designated to maintain NETL's fleet of GSA-leased vehicles, which includes alternative fuel vehicles, all-electric vehicles, and shuttle vans used 4 days a week to facilitate travel between the Morgantown and Pittsburgh sites. An on-site fueling station with storage tanks of E85 diesel and gasoline is used to refuel on-site vehicles and equipment. 2 electric vehicle charging stations are installed to charge government and employee vehicles. Snow removal from roadways is included in site operations and features a dedicated bulk salt storage facility. Field communications capabilities at the facility are enhanced by a dedicated radio repeater system with dedicated channels for operations and other groups. NETL is certified to the ISO 14001:2015 and OSAS 18001:2007 standards, which require environmental, safety, and health conformance. Consequently, conformance to these standards is the basis for NETL's Environmental, Safety, and Health, or ES&H, management system. Key aspects of the lab's ES&H support functions at Pittsburgh include dedicated groundwater monitoring wells and stormwater management and protection, as well as associated sampling. ES&H support functions also include industrial wastewater system operation, which is permitted through the publicly owned water treatment works. The Pittsburgh facility does not currently require an air permit, but air emissions are inventoried quarterly to ensure air quality standards are not being exceeded. NETL is committed to being OSHA compliant. The safety oversight function is provided by a mix of federal and contractor staff. In addition, ES&H program support also includes the safety analysis and review systems, industrial hygiene support, and emergency response support. Much of the research and development at the Pittsburgh campus focuses on wet chemistry. Here are some highlights of our research labs. B83, the Analytical Lab, conducts research on rare earth elements, or REEs, investigating the economic feasibility of recovering REEs from U.S. coals and coal byproducts. The research is focused on developing process designs that minimize or reduce the environmental, safety, and health impact of radioactive and other byproducts of REEs, and optimizing the overall economic benefits of the separation and recovery process. Characterization of materials containing REEs is key to developing technology and processes that will provide reliable and competitive domestic sources of REEs, metals critical to today's technology. B84, the Subsurface Experimental Lab, focuses on enhancing carbon storage technologies through the use of pressure vessels that simulate the pressures and temperatures found deep underground. Studies in this laboratory evaluate the impact of multiphase flow, chemical precipitation and dissolution, and geomechanical stress on flow properties. The Subsurface Experimental Lab equipment makes it possible to accurately characterize geologic formations and predict how carbon dioxide, or CO2, will behave following underground injection. B84, the Combustion Fundamentals Lab, focuses on advanced power generation concepts that utilize oxy-combustion. In this lab, researchers sample product gases from a flat flame burner operated with pre-mixed oxy-fuel with steam and CO2 dilution. The properties measured for the oxy-fuel flame provide valuable data to validate fundamental simulations of advanced energy concepts. B94, the Computations Materials Engineering Lab, is performing research related to using domestic coal and coal byproducts as a manufacturing feedstock for carbon materials. These materials include lightweight carbon fiber composites, carbon additives for construction materials, battery and electrode materials, and carbon nanomaterials. Research takes advantage of NETL's Functional Materials Development Center, which contains 5 floors of synthesis laboratories, instrumentation, and personnel for manufacturing and testing functional materials. Research also takes advantage of NETL's Carbon Materials Manufacturing Facility, which contains specialized synthesis equipment and personnel for processing coal and producing 5 to 10 liter batches of graphene fluids for materials manufacturing applications. NETL's Albany Lab traces its origins to 1943, when President Franklin D. Roosevelt announced that Albany was selected as the site for the new Northwest Electrodevelopment Laboratory. Today, NETL's Albany Research Facility is the site of leading-edge metallurgy and materials research. NETL Albany is composed of 38 buildings, with 253,894 square feet of building space on 43.9 acres, with some buildings eligible for listing in the National Register of Historic Places. In addition to offices and laboratories for conducting cutting-edge research aimed at developing technologies to enhance our nation's energy dominance, the facility includes sheet metal, welding, carpentry, electrical, machine and plumbing shops, a hazardous waste facility, and chemical storage facilities. The lab has an assets replacement value of $115.9 million. 126 employees work at NETL Albany, including 35 federal and 91 contractor staff. Our facilities include bench and intermediate-scale metals fabrication and melting capabilities, a full complement of metal processing and materials characterization, materials performance capabilities, and computational resources necessary to design and engineer new structural materials, advanced subsurface technologies, and direct power extraction. Continued upgrades are required to maintain strong capability in these domains. NETL's capability in structural materials research is anchored by its substantial alloy fabrication and performance testing facilities, which deliver high-performance, affordable materials that enable diverse energy technologies. Researchers specialize in the design, fabrication and manufacturing, performance assessment, and performance prediction of heat and corrosion-resistant alloys. Complementary computational materials research is integrated into these activities to guide alloy development and manufacturing research and to predict materials performance. Research focuses on cost-effective materials for severe stress and corrosive-erosive environments with service life of 100,000 hours. NETL maintains a complete alloy development research capability, which includes the metals melting facility and the metals fabrication laboratory. Because of NETL's scale of alloy production capabilities, NETL's alloy solutions readily translate into industrial practice. This capability has been used to advance the DOE mission and has also been leveraged by other government agencies and the private sector to provide alloy solutions to materials challenges in the defense, aerospace, and biomedical fields. Here are some highlights of our research labs. B4, the metals melting facility, is used to formulate unique alloys designed for use in extreme environments. Metals are developed in the laboratory's high-temperature furnaces, and molds are used to cool the resulting alloy into ingots, which are then heat-treated to homogenize the structure. Formulated metal alloys are machined using a bandsaw, lathe, and other equipment in preparation for hot working in the fabrication facility. The metals melting facility can melt any metals needed for NETL research, resulting in batches ranging from a few grams to over 400 pounds. Alloy ingots are typically produced by air induction melting, vacuum induction melting, vacuum arc remelting, electroslag remelting, or button melting operations. B30, the Metals Fabrication Laboratory, specializes in the research to produce into plate and other shapes needed for assessment of new alloys for use in energy-related applications. Ingots come to the laboratory from on-site melt operations and are formed into plates, sheets, rods, and other shapes. The techniques employed mimic industrial manufacturing processes, resulting in useful microstructures that are key to evaluating a material's performance. Most operations in the laboratory are considered hot working and are performed on heated materials. The laboratory's equipment includes large heat treatment furnaces, a 500-ton hydraulic press, and a 750-ton hot rolling mill. B31. The analytical laboratories allow for the analysis of engineered and natural materials from the nano to macro scale. NETL Albany's petrography and metallography capabilities include optical microscopy, electron microscopy, confocal laser scanning microscopy, and X-ray diffraction. The use of microanalysis, combined with image processing visualization techniques, allows for the identification and quantification of elements and phases of interest. NETL leverages materials characterization capabilities resident at all three sites to provide access to capabilities. B26, the High-Pressure Immersion and Reactive Transport Laboratory, is a multifunctional, state-of-the-art facility capable of performing geological studies at simulated depths up to 10,000 feet, providing an experimental basis for modeling of various subsurface phenomena and processes. The laboratory has a wide range of tools and instrumentation to ensure a complete cycle of scientific studies. The laboratory contains rocking autoclaves and continuously stirred autoclave reactors, which are used to conduct experiments at high pressures and temperatures to investigate geochemical interactions. The laboratory also includes several flow-through systems that can simulate CO2-enhanced oil recovery, CO2 water-rock interaction of core samples under CO2 storage conditions, and simulate the interaction between drilling fluids and the borehole wall. B24. The MHD laboratory is used to perform model validation for magnetohydrodynamics, or MHD, energy conversion applications. The lab is also used to conduct materials performance evaluations for those applications. MHD is a scientific discipline interested in the interaction of an electrically conductive fluid with a magnetic field. An MHD generator is a new type of turbine in which usable electric power is generated without any moving mechanical parts. This process of MHD energy conversion is sometimes called direct power extraction. Major test hardware in the lab includes an oxy-fuel combustion system capable of producing high-temperature supersonic gas flows, a 3 Tesla capable electromagnet, and an ultraviolet excimer laser. NETL is one lab, operating as 3 research sites to provide technology solutions to America's energy and environmental challenges. The Site Operations Support Contract is instrumental in ensuring smooth, productive operations at these 3 research sites in Pittsburgh, Pennsylvania, Morgantown, West Virginia, and Albany, Oregon. For more information on NETL, including business opportunities, visit our website and Site Support Electronic Reading Room.